This video on integration will cover fundamental theorem of calculus, which is integration is the opposite of differentiation. This lecture is conducted by Professor Kenneth Yang, Physics Department, CUHK.
Now this is the most important theorem in calculus. It's called the fundamental theorem of calculus, and to state the concept very simply, it says that integration is the opposite of differentiation. That is a fundamental theorem. So let's see how that goes. So actually, it means just this. Either you differentiate and then you integrate, you get back what you have. So you can either go this way, differentiate and then integrate, you get back what you have. Or you integrate and then you differentiate, you get back what you have. So I will always use this notation, little f and capital F. If I start with capital F and I differentiate, suppose I get little f, then in terms of formulas, it's like this, right? Then you can do the reverse. You start with little f, you integrate, you get capital F. So this is a fundamental theorem of calculus. You can always remember it in terms of that picture. Because it's an indefinite integral, actually when I do the integral, I have to add a constant. So this can be stated in two different ways. The first way is the following. I take small f first. I integrate, I get capital F. That's just a definition. But little f is the derivative of capital F. So I can state it in this manner. That if you first differentiate and then integrate, you get back the same result. This means you first differentiate and then you integrate, you get back the same result. And this is easy to remember. It's like canceling this factor and that factor, right? And whenever you kill this one, of course, you kill that integral sign as well. Or you can state it in another way. Suppose I start with differentiating capital F, I get little f. But I remember capital F is the integral. So I can write it in this way, that I first integrate and then I differentiate, I get the same result back. Do you understand the difference with these two ways of stating the theorem? The previous one says you first differentiate and then you integrate, you get back the same thing. This one says the other way around. You first integrate and then you differentiate, you get back the same thing. They are just two equivalent ways of saying differentiation is the opposite of integration. You take something, you differentiate and integrate, you get the same thing back. Or you integrate and then you differentiate, you get the same thing back. So these are two ways of saying that they are opposite processes. That's two ways of stating the fundamental theorem of calculus. So in other words, differentiation cancels integration. These are ways of stating this theorem. I haven't actually proved it yet. So let me prove this theorem, and I'm sure you all know this proof. Suppose I take a function little f and integrate it from 0 to t, and the answer is capital F. So that is, you do an integration. And the opposite is differentiation. In fact, you can do it with any lower limit. So let's see how you prove that theorem. I make a plot of little f, and I look at capital F at the time t plus delta t. Well, capital F is the integral of little f from 0 to whatever time here, right? So it's the integral from here all the way up to here. Whereas if I take only t, that's the integral only up to this point. If I take the difference by delta f, I mean this one minus that one, is equal to this purple area, which is f of t times delta t. Now f of t meaning the value of f at this point, namely this height. Well, you say it's not quite that height, but that's okay because delta t is very small. whether I take this height or that height or any height here is basically the same. So I have delta f is little f times delta t. I divide by delta t. So if I take the limit, the ratio on the left-hand side is the derivative. So that proves if capital F is the integral, I take the difference between two integrals is equal to the strip, divide by delta t. So that's like differentiating the integral. You get back the original function. So that is a very simple way of proving this fundamental theorem.